This is AP Calculus AB. We are looking at connections of the graphs of f, f prime, and f double prime. Given below is the graph of the function f. State all of the conclusions that you can make about the graphs of the first and second derivative. Justify each of your conclusions. So I tried to guide us a little bit here, what we're looking for. When is f increasing? F is increasing on this interval from negative infinity to negative 4. And it's increasing from negative 2 to 1. It's negative infinity to negative 4, non-inclusive, and then from negative 2 to 1. So what conclusions can we draw from that about the first derivative? That must mean that f prime is bigger than 0 on these intervals. When is f decreasing? F is decreasing from negative 4 to negative 2. And then it's decreasing again from 1 to infinity. What conclusions can we make about f prime? Well, if f is decreasing, that means f prime is negative. It's less than 0. F of x has extreme values, extrema, at x is negative 4, x is negative 2, and x is 1. What conclusions can we draw from that for f prime? That means that f prime has to equal 0 at these x values, which means it's crossing the x-axis there. What degree is f of x? Well, it looks like it could be fourth degree, but for sure we know it's an even function, even degree function. Let me say that, even degree, because both n behaviors are the same and it appears to be a polynomial. So we can certainly say it's even degree, maybe the fourth degree. We can definitely conclude from this that f prime has odd degree, and it's likely cubic if that was quartic. What conclusions can we make about the second derivative? Well, when does f of x have a relative minimum? That's happening here at x equals negative 2. And what's also happening there? The graph is concave up. What conclusions can we draw from about the second derivative? Conclusions that we can draw is that f double prime has to be bigger than 0 at this x value. F double prime has relative maximums at x is negative 4 and 1. And it's also concave down there. So the conclusions we can make about f double prime is that it's bigger than 0 at these x values.
As a correction, I misspoke and miswrote here. If f has a relative maximum, it's concave down, f double prime is not greater than 0. It is less than 0. That's a huge, huge, huge deal. My apologies, and that needs corrected to be less than.
F, once again, is an even degree, probably quartic. So f double prime, if you think about it, has to also be an even degree. because the derivative would be odd, and then you subtract 1 from the odd exponent, and it's going to turn back even. So once again, this is even. You subtract 1 to get the derivative. It's going to be odd degree. Subtract 1 again, and then it's going to be even. Subtract 1 again, it's going to be odd degree. So those are some conclusions we can make about this graph, about the first derivative and second derivatives. And the next example, we will look at something a little bit different.